Yes, students, hope you would have done most of the uses of dimensional equations. So just wanted to give you an idea about what is there in the book. So you have the first use as to convert the units of one system of units to the another system. So you see here, so the use of dimension, so to convert the unit of one system to another one. So you find this particular thing and you find the system of conversion. N2 you find, N1 you know, and you put the dimension of both of the one and you get the final result. You already saw a video and you already saw how to do an example also. So the next one is to check the correctness of the equation. So any equation, if you have an equation like this, you can check the dimensional equalities of the left hand side. You can prove it, and you can right hand side also you can prove it. If it is equal, then you find the dimensions are equal. So the dimensions of any equation can be checked, and we can check whether the equation is correct or not. So this is the second use of the dimension analysis, and you would have already done some of the questions based on those examples that have been sent. So this is also a very important application which is there. And the third use of dimension analysis is to establish the relation among various physical quantities. This one has quite a lot of numericals, which has a lot of importance also for the examination point of view. So you would have seen how to do this one. So you find mass, length and acceleration due to gravity is there. Time is the one which is been given as this side, and the quantity of A, B and C can be found using the dimension analysis. So once you go through this one, you will be able to make a final answer of what the equation of this particular relationship it could be. So after putting the dimensions of all these quantities for mass and the length, and as well as the next quantity as acceleration, then you will be able to get all these quantities and you will be able to find A, B and C using this particular relationship. So finally you get this value as time period is equal to K times of under root of L upon G, where G is acceleration due to gravity, L is the length, and you get the under root value also. So this is one of an example that you already seen this one. So you also already done some of the numericals also. So what we're going to do today is we're going to see some of the example questions in the book. So you have turned to page number 86. So from page number 86, example number 3 and 4, it could be done easily and you would have done also. Now we are going to see example number 5. This example number 5 has a little different way of solving this. So I thought I will just work out this example for you. When a stone falls freely, the height it falls in a time t is given by the equation h is equal to ut plus half gt square, where u is the velocity of the stone at the time of drop. Find the dimension and units of u and g. So this is the question that we are saying here. So how to solve this one, I'm just going to do in front of you so that you can understand this particular question. So we see here question number 5. The equation is given here, h is equal to ut plus half gt square, where u, it is already given in the question as velocity, t is time and h is height. So find the dimensions of u and g. That's what it's written here. We need to find the dimension of u and we need to find the dimension of g. These are the two variables which is here and we need to find out. Now how to find this particular thing is, first of all you should know the basic principle. It governs through this. This is height already given here, and u into t, that's one identity is here added by another group of identity. So ut plus another group is half g t square. You should remember one thing, height should be equal to, this also should be height, and the next one, this also should be height. Height is equal to height plus height. That is the simple logic it works. If you add height and another height, you will get the answer as height. Or maybe the distance plus distance is equal to another distance. So keeping that as a basic idea for us, so we find here as u in t as one of the identities, and next one is half g t square is the other identity. This should have the same dimension of length. This should also have same dimension of length. It's very straight and clear for us. Now how to find out this dimension here, how to do this one? Now put forth here, this is u, we don't know this dimension. This is t, capital T is the dimension of the time period here. That should be equal to L. So how to go about? U is equal to T L upon T. In other words, L T minus 1 is the dimension of U. So that has been very clear because of the fact that height distance is equal to distance plus distance. This entire quantity should become a distance. This also entire quantity should become a distance. So we had here half g t square also should be having the same dimension of distance here. So going forward further, half g and t square should have the same dimension of length. Now g is a constant, we know this one, but this dimension they have not given, they have asked us to find out. Half is a dimensionless quantity. So dimensionless quantity is half. So we don't have any dimension for this one. So I'll write dimensionless. And g is the one which you need to find out. T is already there. We know this one. G into t square is equal to L. And g is equal to L upon t square, which is equal to L t minus 2. So this is the formula for this one. So you got the answer for U, you got the answer for G. You're also asked to find out what is the SI unit of this one. What is the unit of this one? If the unit of this one, it's going to be length and time minus 1, it is going to be meter second minus 1. And here it's going to be meter second minus 2 will be the SI unit of this one. So here we find the next question, example number 7. Find out the units and dimensions of the constants A and B in the van der Waals equation. P plus A by V square times of V minus B equal to R into T, where P, V and T, they are given as pressure, volume and temperature. So these are the quantities which is given here. Capital R, we already know it is a gas constant. So PV is equal to RT is a gas constant, which is the equation, gas equation. And based on this one, van der Waals equation also is made. We are supposed to find out the dimension of A and B. So let us try to solve this particular question. So I have written the basic equation here. The equation is P plus A by V square equal to V minus B equal to RT. The same principle applies here also. Pressure plus this entire quantity should be pressure. Then when we will be able to find the dimension of this one. Similarly, volume minus this quantity also should be volume, because volume you can subtract 1D by volume. Pressure you can add 1D by the another quantity of pressure. So this is the basic dimension rules. So if you want to find out A by V square, we can write here as this P plus A by V square. This entire quantity should be dimension same as pressure. So A by V square is equal to dimension of pressure. So what is the dimension of pressure? We already know this one. Force upon area. So mLT minus 2 upon area is L2. So A upon, what is this V? It is going to be L cube because it's volume. Volume the whole square is equal to mLT minus 2, and this L2 also can go up. So we can, for this particular time, we can keep it here. So what is A is equal to, this whole quantity goes up, L cube and the whole square, it becomes L6. So once it goes up here, mLT minus 2 L6 upon L2. This one and this one gets cut, you get 4, so it's going to be equal to mL5 T minus 2. So that is the dimension of A. You can also find out B also like this. V minus B. V minus B. It should be also volume then. So V minus B is equal to dimension of volume. So B should be equal to L cube. So that is a straight answer you get here. So this is a very simple question and also a very important question also. So the next question is example number 8. Find the dimensions of the constants A and B in the relation P equal to B minus x square divided by AT, where P is power and x is distance and t is time. We can easily solve this question. So the expression is written here, P is equal to B minus x square upon AT. We need to find out A and B in this expression. So looking at this thing, so I've written this one. P is given here and P is power, x is distance and t is time. We need to find out A and B. Look at this one very carefully here. This is B minus x square. This is distance. Distance square minus what should be this dimension also. This dimension also should be distance square. So we have a straight answer here to find out for the value B. So B minus x square, it should be equal to distance square. So it is distance square. So what is going to be B equal to? It's going to be equal to L2. So that is a straight answer that you get here. The next one is, we need to find out the value of A. So A, if you wanted to find out, this is distance square, this whole thing is distance square upon AT, and then we need to put the formula for power. So when you have the power formula, we'll be able to make this one out. So going ahead to solve this one. So as you solve this one, we have to transfer this A quantity over there and bring P over there, so that you will be able to cross multiply these two things. So I'm writing here. So it goes on like this. A is equal to B minus x square divided by power into time. Now we need to put the dimension of all of them. B minus x square. This entire thing we already understood. It is going to be x square minus this also should be x square. That could be distance square minus distance square. So we have to put the entire dimension of the top quantity as L2 divided by, now we should know by heart the dimension of power. Power is going to be equal to energy into time. So the work done per unit time is the power. So we'll be able to make this as mL2 t minus 2 divided by time. So energy per unit time into time. So t is time here, this is power. These two gets cancelled out. Here also L2 and this one also gets cancelled out. So what will be the remaining one? Mass will go up, m minus 1. T will go up, T2. That's going to be the dimension of A. So we have found A and we have got the dimension of B also here. So both of them has been found out here. The next question is example number 9. Find the dimensions of A upon B in the relation F is equal to A under root x plus B t square, where F is force and x is distance and t is time. So we have these quantities are given here. Force is given here, x is given there, t is given there. Time, distance and force. We are asked to find out the value, the dimension of A and B, and later on we have to divide these two dimensions and get the final relation. So we'll try to do this question. So the same question has been written here in relation F is equal to A under root x plus B t square. Now remember this one, this is force. This is equal to force plus another force. This also should be the force. This also should be force, and added together force plus force will give you then final addition quantity of force. So if you look at dimensionally, this quantity should be fully equal to force itself. So we are going to write this one. This one is going to be equal to force. So A under root x is equal to force dimension. Now let us put the dimension here. A under root L is equal to force dimension is ml t minus 2. So what is A is equal to? ml t minus 2 upon under root L. So you can, if you try to do the final calculation of this one, you get here half and m minus 2, t minus 2. So that will be the value of A. Now how did I do this one? Here you will get here under root L. So L can be divided into under root L and under root L upon under root L. So we try to imply this L into two parts, under root L into under root L. So this two gets cancelled out. So you get only under root L here in the top. So that has become half here. Now the next one is force should be equal to this also. The total quantity should be equal to force. So B t square is going to be equal to force. So B t square dimensionally equal to ml t minus 2. This one goes down. So equal to B equal to ml t minus 2 upon t square. It goes to the numerator. You get t minus 4. ml t minus 4 is the formula. This is the dimension of B. Dimension of B is we have got. Dimension of A we have got. So what is the final thing you need to find out? A upon B. So A divided by B. So what is A? That is dimension is equal to m L half t minus 2 divided by m L t minus 4. So this one will get cancelled out. You get minus 2 here. So here this will get cancelled out. You get half here. This also will get cancelled out. So what you get here is 1 upon L half and t minus 2. When it goes to the numerator, this L minus half and t2 will be the dimension of A upon B. So this is going to be the final answer for you. Example 10, we are going to see now. Find the dimensions of omega and k. In the wave equation, y is equal to a sine omega t minus kx, where x is distance and t is time. So we are given a wave equation y equal to a sine omega t minus kx. So y is also a displacement. A is also an amplitude of the wave. Sine, we already know it is a sine quantity of this one, omega t minus kx. So we'll try to solve this question, how it goes. This equation is already written here. X is distance, it's already given there, and t is time. What we need to find out is omega and k. Remember one important thing, any quantity which comes inside the sign within bracket, this entire quantity will be dimensionless. Omega t minus kx, the full quantity, all the quantity put together, it is dimensionless. And also sine is always an angle here, sine theta, this entire thing will be considered as a theta. Theta, we know it is dimensionless. So sine theta is also fully dimensionless. So remember this important fact. Anything within the bracket of sine theta or cos theta or tan theta, any other identity of trigonometry identity comes, that within bracket it is dimensionless. So that has to be very, very clear for all of us. So omega t minus kx also should be dimensionless. That means dimensionless quantity minus another dimensionless quantity will be equal to another dimensionless quantity. So the total thing is dimensionless, means this should be dimensionless minus another dimensionless quantity should be there. So we have a value as, what it is here is, how we go about omega t, it should be dimensionless. So omega into capital T is equal to m0 L0 T0. So omega is equal to, omega is the value which is here, this goes down here, so m0 L0 T0 upon T. So finally what you will get here is just T minus 1 will be the dimension. In other words, you can write here m0 L0 T minus 1 also you can write, that is the dimension of here. Remember one thing, this omega t, the entire omega t is dimensionless. Why it is dimensionless? Because sine value always it is dimensionless. So entire the angle which is also going to be dimensionless. So you can keep on adding or subtracting any number of identities here. All of them as a single identity will be dimensionless. Dimensionless minus dimensionless should be there. Then only you can subtract. So that's the way it is. Going further to the next identity, kx, we are going to find out k also. Kx also it is going to be dimensionless. So kx is equal to dimensionless. So k into dimension of distance here, it is m0 L0 T0. So what is k? It is going to be equal to m0 L0 T0 divided by L. So k equal to m0 L minus 1, it goes up there, and T0 will be the dimension of this one. So we got the value of k in this fashion. Remember the basic fact. This basic fact has to be always remembered. Sine inside quantity is dimensionless. Then we can solve this equation very easily. The next question is example 11. A book with many printing errors contains 4 different formulas for displacement of a particle undergoing a certain periodic motion. First equation is given here, second equation is given here, third equation, fourth is given here. So there is a problem with some of the equations. So we need to identify the wrong formula on dimensional ground. So we need to rule out what are the wrong formula on the basis of dimensions. A is maximum amplitude, maximum displacement is given here, that is called amplitude. V is speed of the particle. T is time period of motion. These three quantities are already identified here. So we need to find out this particular thing, which are the formulas are wrong formula we need to identify. So I have already written this question, rule out the wrong formula. So the first question is y is equal to a sine 2 pi into small t upon capital T. And all the terms are given here. This A is maximum displacement, that is called, otherwise called amplitude also. This one will have the dimension as L itself. L is the dimension of this one. Velocity of the particle, we already know LT minus 1 is going to be the dimension of this one. T, there's just a time period here. And then T also, here time period only T here. And displacement will be L here. Now, having said this one, so we need to find out what could be the reason if this is wrong or it is right. First thing is, whenever you see a formula like this, it is sine. This entire term, it's going to be dimensionless. Why? Because this is going to be an angle here. Angle is dimensionless. 2 pi small t upon capital T. It quite verifies here as, first of all, 2 pi small t upon capital T. Is it dimensionless? 2 is a constant, pi is a constant, no dimension. Small t, it is capital T is the dimension value of this one. Next is also time period. Again capital T, these two gets cancelled out, so you get here M0, L0, T0. This inside term is totally dimensionless. It is already proved here. So this particular part is correct. We need to find out the next one, whether y equal to a, is it a right dimension? Yes, y is also, capital L is a dimension here, and this a is also, capital L is a dimension because that's what's given here. L is a dimension of this one, and y also is L. So these two quantities are LHS is equal to RHS here. So this entire formula is going to be correct. So there are two reasons that we need to find out. One is inside the sign identity, whether it is having a dimensionless quantity. Once this is correct, then we move on to the next verification. Y is equal to A, this entire thing is dimensionless. So y is equal to A. Is these two prove to be an equal dimension? Then it is correct. So y also it was L, A also it was L. So this entire formula is correct. The next formula here. So I can write here as, this formula is correct formula because of the fact that these two are also equal. The next one is y is equal to A sine V into T. So using the same principle here, sine is going to be a trigonometric function. This is going to be theta here. So V into T should be, it must be dimensionless. But let us find out what it is. This is LT minus 1 is velocity here. This is capital T here. So if this capital T and T minus 1, when it is going to be here, it can get cancelled out because T minus 1 and T, it can get cancelled out here. So finally you get a dimension of L here. It is not exactly dimensionless. It has a dimension here. Since it is a dimensional quantity, sine Vt can never be possible to be as an equation. You can never write like sine times of V into T. For velocity into time, you can never write in for the time term. So you can write here as L is a value here, since the trigonometric function has dimension, this is not correct. This is the wrong formula. So we identified, and we can be able to give this as a reason here. Next question here, there is a third question here. Y is equal to A upon T sine T upon A. Looks like again another tricky formula, sine T upon A. We know this one, this should be dimensionless because sine term totally it should be dimensionless. T upon A, when you try to do the dimension part of it, this is T, and A is also distance here, it is L, which gives here T L minus 1. This again says sine term is having a dimension here, so it is going to be wrong formula here. So since sine T upon A has dimension, this is wrong formula. We'll see the last question here. Y is equal to a upon under root 2 sine 2 pi small t upon capital T plus cos 2 pi small t upon capital T. This looks to be a very big expression. Don't be afraid, it is not so difficult. Sine 2 pi upon capital T will try to knock down 1 by 1. Cos 2 pi small t upon capital T. So if you take 2 pi small t upon capital T, this identity, now this is a dimensionless quantity, this is also a dimensionless quantity. This is going to be capital T is a dimension upon capital T is a dimension. So you get here M0, L0, T0 for this whole thing. Similarly here also it is dimensionless. M0, L0, T0, it is dimensionless. So since this is dimensionless, this is also dimensionless, so we can easily say this is correct, this is also correct. So we will be able to make a clear statement as inside the sign quantities, this entirely it makes it as a sense. So whole thing, this is dimensionless plus dimensionless quantity, it makes sense for us. But we need to identify one more time what happens to these two things. If this entire thing is dimensionless, fine, but y is equal to a upon under root 2 into a dimensionless quantity here. Alright, so can these two things make it equal? So we know y is equal to capital L is a dimension and a upon under root 2. So here a only will have a dimension here, that is also capital L, whereas under root 2 will not have a dimension here. So this is also kind of a, you can write it as RHS, this is LHS, and both of them are equal. So this equation is correct. Y equal to a upon under root 2. This picks it. This also dimensional is L. This also dimension is L. This entire thing is dimensionless. So this is a correct equation. So this is correct. This equation correct. So please make sure first of all to see what is there inside the sine term. If the angle is there, angle should be dimensionless. Once this is proved, then you come out of the bracket here and see what is the left hand side and what is the right hand side in this side. And if you prove these two also, then it is quite a final way of doing it. Yeah, this question was given to you as a homework on the other day, fourth question, which is there in the same place when you see it as to check the correctness of the equation using dimensions. In this one, you are given all these other questions here, that is the 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 6 also you did, and this also was given, fourth was also given. I still have a doubt whether you would have been able to finish this question, so let us try to solve this question. Refractive index mu of a transparent medium varies with wavelength lambda of the light. Mu equal to a plus capital B upon lambda square, where a and b are constants. Find the dimension formula and SI unit of a and b. We need to find out what is the dimension of a, what is the dimension of b, and as well as we need to find out the SI unit of both of them also. This is also a pretty simple question. Only thing is, if you know the basics, you'll be able to apply it. Mu equal to a plus b upon lambda square. Remember, mu is refractive index. So what is the refractive index? Refractive index is also just a number which doesn't have any unit, and it is a ratio of these two things, velocity of the medium in one medium and velocity upon velocity of the other medium. So velocity and velocity, the dimension gets cancelled. So a refractive index basically is a dimensionless quantity. So we can write here as this is dimensionless. Wavelength, this is just a length, distance. We measure wavelength by just distance. So here the dimension is going to be L here. So if you see here, refractive index is equal to a plus b upon lambda square. This should be dimensionless, means this also should be dimensionless, plus another dimensionless quantity. This entire thing is going to be dimensionless plus another dimensionless quantity. Added together, this will be a dimensionless. So the first conclusion is A should be dimensionless. So A equal to M0 L0 T0. This is the formula for A. B also we can find out like this itself. How do you find out B? Because B upon lambda square should be dimensionless. M0 L0 T0. So B upon lambda square is already given here. So this has to be cross multiplied. B upon L2 is equal to M0 L0 T0, and B equal to, this cross multiplies, M0 L2 T0. This is going to be the dimensional formula for B. And keeping this also, we can find what is the value of this. A, what is the SI unit? It is no SI unit because that is a dimensionless quantity. And B is going to be meter square, is going to be the SI unit. So let us see one more question. This could be the last question for today. The time dependence of the physical quantity P is given by P is equal to P naught e to the power of minus alpha t square, where alpha is a constant and t is time, and the constant alpha is, there are 4 options given here, we need to find out what's the option it is. So this is going to be a little different and tricky question here, and it is asked in a competitive exam also. So it's a multiple choice question. So this formula is written here. P is equal to P naught e to the power of alpha t square. Now we are seeing this term for the first time. What is E? Now E means exponential. Exponential part, whenever there is an exponential part, remember, this also the whole thing remains dimensionless. Exponential is also dimensionless quantity. So remember this one, this should be dimensionless. That is already a written rule of this. All the exponentials are dimensionless. Similarly, all the logarithms also dimensionless. Anything of log is coming, that is going to be dimensionless. And we have just now saw this one, all the sine thetas, sine, cos, these are all dimension, tan, dimensionless. So sine, cos, tan, log, and this also comes in the same variety. Exponential of anything, the entire thing is going to be dimensionless. So if this is going to be dimensionless, the top power should also be dimensionless. So this power should be dimensionless, then one day it will be able to make it as a dimensionless quantity. So alpha t square, it is also dimensionless. So putting dimension here is equal to M0 L0 T0. So what is alpha is equal to M0 L0 T0 upon T square, So this can go up M0 L0 T minus 2. That is alpha. So alpha has a dimension of this one. So it is already given here. So what is alpha? It is T minus 2 is going to be the final answer for this one. Now this is P and this is P. These two things could be the same dimension. If this is it has one dimension, that dimension should be equal to this dimension also, and this entire quantity is a dimensionless. We have asked only for finding a dimension of alpha, so we have found this one only. So it is nothing else is asked, so we can just leave it here itself.